Here is a problem where our situation is that we have some frictionless surface, and on one side we have a woman, we'll label as W, and on the other side we have a man, who I will label as M. And then the details of the problem are given. We have both of their masses, and we have the distance between them. The first part of the problem asks us to find the location of the center of mass with respect to the woman's position. So to do this, I'm going to define a single coordinate axis, and because the problem specifies from the woman, I'm going to set the origin to be at the woman's original location. Now finding the center of mass is pretty simple, especially when we only have one axis to work with. The general formula for the center of mass tells us that it is generally equal to the sum of the products of the mass of each element of the system times its position. So the mass of the woman times the position of the woman times the mass of the man times the position of the man, all divided by the total mass of the system. So divided by the mass of the woman plus the mass of the man. And this is pretty simple, the information given to us. We're given the masses of both the man and the woman. The variable for the woman's position is just going to be 0 because we've defined her position to be the origin, and x sub m, the man's position, is going to be 10 meters since he's 10 meters away from the woman. So if we put all this into our calculator, we find a position of 5.806 meters. This means that the center of mass of the man-woman system is this distance away to the right of the woman's position. Now the next part of the problem asks us to imagine that there is a rope connecting the man and the woman. The man pulls on the rope, which causes him to slide to the left by a distance of 2.5 meters. And we now want to find the distance between the man and the woman in this case. Now the important thing here to realize is that since there are no external forces acting on the man-woman system, the center of mass should not change locations. So if the man is moving to the left, then the woman must be moving to the right as well. So you can't simply take 10 meters and subtract 2.5. Fortunately though, since the center of mass location won't change, and we just found that location, we can simply take xcm to be 5.806, and then use this exact same formula again, except this time solve for the position of the woman. So let's solve for x sub w. First thing I'm going to do is take both sides of this equation and multiply it by mw plus mm, so that we can get this stuff from the denominator out of the way. Then I'm going to subtract both sides of this equation by mmxm, and then divide both sides by mw. This will get xw on its own. And this is what our formula looks like now for the woman's position. So for x sub cm, we'll just use the answer that we got for part A. And for x sub m, the position of the man, we can't use 2.5, we have to use 7.5, since that's 10 meters, the original distance between them, minus the distance that the man slides to the left. And for x sub m, the position of the man, we can't use 10 meters anymore since the man has moved 2.5 meters to the left, so now we'll have to use 7.5 meters, which is 10 minus 2.5. So if we put all this into our calculator now, then we find a value of 3.460 meters. This is the new position of the woman with respect to her original position, the origin point. So to find the distance between them, we can just take the man's position, 7.5 meters, and then subtract this, which will give us a distance between the man and the woman of about 4 meters. For the final part of the problem, we're asked to find how far the man will have moved in total once the pair collide with each other. Once again, there are no external forces, so the location of the center of mass has not changed, and that's the point at which they'll collide. Which means all this part of the problem is really asking is how far the man has moved from his initial position of 10 meters to the center of mass location that we already determined. Which means that this part of the problem is as easy as taking 10 meters and subtracting 5.806. The answer is about 4.2, So the man has moved about 4.2 meters to get to the point where he will collide with the woman. I wish I only had to move that far to find myself a woman. That's all for now, and I hope this video helped you out. If it did, please consider subscribing since that supports me immensely in making more of these videos. And if you have any questions, leave a comment down below and I'll try to help you out. I also have a Discord server linked in the description, where I take requests for future video ideas. But that's all for now, and I hope you have a good night. Bye-bye.